Welcome back, Chemistry 30. So we looked at weak acids. Let's look at weak bases. We'll see that there's a very similar relationship here. So many substances behave as weak bases in water. Weak bases react in water, but this time, like acids, give up H to the water to make hydronium. Bases take an H away for every water molecule to form the OH minus ion. So react with water, abstracting protons or H plus from H2O, thereby forming the conjugate acid of the base and the ions. Same thing here, equilibrium constant, products over reactants. Again, we exclude water. And again, look at that. The little subscript is not an A, it's a B to represent this is a base acid dissociation constant. Water is the solvent, so it's omitted, and we get simply that. As with Kw and Ka, the subscript B denotes that equilibrium constant refers to the particular type of reaction. In this case, it's a weak base. The constant Kb, the base dissociation constant, always refers to the equilibrium in which a base reacts with H2O to form the conjugate acid and OH. Table below lists some Lewis structures and of conjugate acids and Kb values for a number of weak bases in water. These bases contain one or more lone pairs of electrons because a lone pair is necessary to form a bond. So there's an example right there. A bunch of, and then look again, the strongest of the weak here, 1.8 times 10 to the minus 5, which is ammonia. Right, so we'll do the same thing. We'll do the same type of question here with bases. We'll calculate Kb when we have pH and then vice versa. So a 0.15 molar solution of ascorbate ion has a pH of 8.65. Calculate the Kb. So we handle this the same way, ladies and gentlemen. Make the ice chart. So initially we have that. Now water, that gets excluded from the Kb expression, so we don't need to worry about it. Starting off with 0 and 0. Then again, we're going to subtract some, add some, add some. Now, we have the pH. So what we can do is figure out what H is first of all. Now again, on your formula sheet, there's a couple of different ways we can do that. Inevitably, we need to go from pH to OH. So I can figure out what H is first, and then, figure out what H is first, then forget OH. Or I could figure out the POH and then figure out OH. There's more than one way you can do it. So you can look, I'm going to do it one way. You certainly can do it the other way. We should get the same answer regardless. So the H here works out to be 2.2 times 10 to the minus 9 molar. And then, of course, if I know what H is, I can figure out what OH is, because I need to multiply to give us the water constant. 2.2 times 10 to the minus 9 times OH. So it's a little extra step here for the base question, because we need to know what OH is as opposed to H when we're dealing with acids. So OH works out to be 4.5 times 10 to the minus 6 molar. And that's what it would be at equilibrium. So 4.5 times 10 to the 6. I kind of didn't leave a lot of room here, so I'm going to have to squeeze that in. 4.5 times 10 to the minus 6. 4.5 times 10 to the minus 6. And since this is all 1 to 1 to 1, minus 4.5 times 10 to the minus 6. And I think we'll see that we get 0.149 repeating. All right, so there we go. We have it all set up. The Kb products do I have that right? Yes, I do. Over reactants excluding water. C6H6O6 negative. So we have 4.5 times 10 to the minus 6. 4.5 times 10 to the minus 6. All over 0.149 repeating. And with that we get 1.35 times 10 to the minus 10. I can go two sig figs here, I guess. 1.4 times 10 to the minus 10. So there you go. That is how we do that. Well, just like that, just like we did with the weak acid when we could go vice versa. By knowing what the Kb is, figure out what the pH is. So we could look at it vice versa, calculate the concentration of OH, and then calculate the pH of the solution as well. We know what Kb is. We know initially this is 0.15. We don't care about H2O. We're starting off with 0. So that's the initial part of the ice chart. Ice. And of course, so we don't care about H2O. Let's see here, because it doesn't occur in that final expression. We're going to add something. We're going to add something. And we're going to use up some over here. Now, we don't know pH. We're going to figure that out. So just like before, we don't know, so we can put in an X. One makes one. It's all one-to-one relationships here. So we can have it like this. And you can see here we're going to make an assumption here as well. Kb equals product over reactants with water excluded. Kb, 1.8 times 10 to the minus 5. X times X. And again, we're going to make this little assumption here on the bottom. Assume X is very small, because these are weak bases. They don't dissociate that much. So X will be a small number. It's like comparing 5 cents to $10,000, of course. Doesn't make a difference. Compared to 0.14, so it is omitted from that bottom part there. So I'm going to just move everything over to here. So 1.8 times 10 to the minus 5. X times X is X squared. If I just get rid of X there, it says 0.15 on the bottom. And again, so multiply each side by 0.15, then square root. X is going to be equal to 1.6 times 10 to the minus 3 molar. Okay? Therefore, now what does X represent? Oh, it represents hydroxide at equilibrium. Therefore, OH minus is equal to 1.6 times 10 to the minus 3. All right. And then from there, I'm asked to figure out pH. Now, on your reference sheet here, I can go and figure out POH from OH. And then from there, I can use the relationship between pH and POH to figure out the pH. So negative log of 1.6 times 10 to the minus 3. So that's going to give me 2.8. And of course, pH plus POH adds up to be 14. So if I know what POH is, I can certainly figure out what pH is. 11.2. All right, there you have it, ladies and gentlemen. So weak acids and bases, a little bit more work because they only partially dissociate, partially break down. So that's where the Ka comes into play in Kb, and of course our relationships from our pH formula sheet. All right, should be able to do this assignment. I think you have 2 weak acids and 2 weak bases, very similar to these questions that we've done together here. All right, we'll see you again.